Hi, I'm Matt Sprague, host of the Connected Construction Show, and I have a special announcement for our audience. This November 7th through the 9th, Trimble is hosting their Dimensions User Conference at the Venetian in Las Vegas. And they've just given us 2 tickets valued at over $1,700 each to give away to our audience. So how can you win? Simply share your favorite episode on any social media platform using the hashtag CCShow_favorite and include why that's your favorite episode, and you'll be eligible to win. The shared post with the most amount of likes will win 2 free tickets to Dimension 2022. 5 runners-up will receive a special Connected Construction Show t-shirt and sticker, so get out there and share your favorite episode before October 21st. We will announce the winner live on the show Tuesday, October 25th. Again, share your favorite episode on any social media platform using the hashtag CCShow_favorite and include why that's your favorite episode before October 21st in order to have a chance to win the 2 tickets to Dimensions in Las Vegas. Good luck and stay connected.
From Trimble Construction, you're listening to the Connected Construction Show, where we connect you to the contractors, owners, designers, engineers, and construction professionals who are finding better ways to work. And now, here's your host, Matt Sprague.
Hello and welcome back to the Connected Construction Show. I'm your host, Matt Sprague. I'm excited to have all of our listeners and our viewers back, but very excited to have this week's guest. We have Øystein Ulvestad from Sweco joining us today to have a incredible conversation around the use of 3D models, BIM for infrastructure. Super excited to have you. Welcome to the show.
Thank you very much. A pleasure being invited. I've been looking forward to this.
Nice. And tell the audience a little bit about yourself, where you're from, where you're located, who you work for, what you do for them.
Yeah. My name is Øystein Ulvestad. I'm a structural engineer. Born and raised in Norway, now working in Oslo, Norway for Sweco, as you say. I started doing structures and sports arenas, and then for the last 10 years I've been working with bridges mainly, and then more and more 3D modeling of bridges. And then we had this very exciting development in Norway where the government has accepted BIM models instead of drawings when doing third-party control for bridges. So I guess that leads us to today.
Absolutely. So the first question I kind of wrote out for you was kind of tongue-in-cheek in terms of, like, I hear you really love 2D drawings. Tell me about that.
Yeah, the first maybe 5 years of my career was AutoCAD 2D based. So I had my share of doing reinforcement drawings, form drawings in 2D, and in some ways that was a very good way of learning. But it also got me very frustrated in what you didn't see in 2D. So then I started using Tekla structures back when it was called X-Steel something, and then you suddenly had this third dimension, and I love that. But you still, finishing your 3D model, had to dumb it down to 2D drawings. So then again, you would have a better understanding of what you were doing, but still you lost that third dimension when you handed over your product. Yeah, you're right. I do love my occasional drawing, but not all the time.
So I think you have like a professional mission. I wouldn't say it's a life mission, a professional mission for deaf to drawings. Is that accurate?
Yeah, I'd say that's pretty accurate. I'm very happy when information can be transferred in other ways than drawings. that's not possible all of the time, but it's more and more on more and more occasions we see that we can do 3D models when we deliver products to builders, and yeah, now I'm very happy when we can do that.
So you had mentioned within Norway anyway that bridges have solely moved over to 3D modeling, BIM modeling. So how common is utilizing model-based, drawing-less design and construction across not just bridges, but like all other pieces of infrastructure, but also vertical construction as well? Where is that evolution within at least Norway, but also maybe just between what y'all doing with Sweco?
When it comes to structures, you don't have such a rigid third-party control as you have with bridges. So there, I think model-based, drawingless deliveries have been more common for a long time. But with bridges, you have this very rigid control scheme where things have to be controlled by a third party. And I think it's 5 or 6 years ago, the Norwegian road authorities opened up that those deliveries could be done either by drawings or by BIM models. And then this revolution started with companies trying out different ways of doing this. And so we've had about 5 or 6 years to mature now. And I think nowadays about 1/3 of all deliveries in Norway, so 1/3 of all bridges built, are built based on only BIM models, no drawings.
Interesting. So I have this curiosity question in terms of diving into like why skip the drawings? What are the benefits of the 3D model? But I instead of just answering that, I figure it might be better to explore a really unique use case. So there was a Fast Company article written back in June that was I think it was titled the 2,000-foot bridge was constructed without a single drawing.
That is
so. And you were intimately involved with that one. So first of all, listeners, watchers, we'll put that link to that article within the description of this show. But also, so let's take us through that. Tell us as much as you possibly can about that project.
Yeah. So in late 2018, we got this contract for a. Well, in meters, it's 634 meters. And we were asked by the contractor, who had never done any of these bridges without drawings before, if they thought this was suited for this way of this methodology. They were very interested in learning how to do it, but they had no experience from earlier projects. Our experience was about 10, 12 bridges. That was about, say, the longest one was maybe 150 feet. So we thought we had quite a lot of experience, but then again, this one would be over 10 times as long. So we had to sit down and say, do we have the resources, the technology, the software to do this? And I remember a moment where the head designer, he'd maybe done 10 of these very large structures, and then he was looking around at his engineering team. Normally he would have draftsmen that were maybe average age of 50 or 60, very experienced draftsmen. And now he was looking at a team of average age of maybe 26 or 27 years of age, because these were computer engineers. They had to program this instead of drawing it. he was extremely skeptical. And then after this discussion, we managed to convince him that this would be the way forward, and that we would be able to do it. And then about 1.5 years later, the whole model was finished. It had been improved. We had Corona in the middle of this, so we had to put all work. We had to stop all work at site for about 3 or 4 months. But then after 1.5, 2 years, we were nearly finished with everything, and we saw that this way of building a very, very complex structure actually worked. We were very confident all the way that we could make it work, but the joker was, of course, the company that had never done this at site before. But they really, really achieved well. They helped us. Well, together we overcame all the obstacles that popped up, and I'm very happy to say that we now have a very beautiful working bridge that you all might come and drive over if you're ever in Norway.
I guess the operable piece there is it's a functional bridge.
Yeah. Yeah. No, it's at least from what I know, it's still the longest structure in the world that's ever been built without drawings. I know there are some projects, I believe in China, that's also now being done without drawings. But I still believe it's the longest structure in the world and built without drawings.
Yeah, even if somebody beats you, then you're the ones who started it all. So it's a great accomplishment. So now you mentioned that in terms of you referred to the challenges. You've never, like you said, it was 150 feet prior to that, going to over 2,000 feet, 600 and some odd meters. So what were those challenges? Like where were not only the technological well, maybe they are all technological challenges, but where were those kind of bottlenecks and issues?
Mm-hmm. I think the first challenge was that this was done. Part of the design calculation team was in Portugal, and part of it was in Oslo. So we had to do something that was cloud-based, and the model. We knew that at the end it would contain about 300,000 objects. So it's quite a large model. So you need cloud-based solutions that work well. So that was one obstacle, but that was a lot less problematic than we thought it would be. Another one was that I don't know if you're familiar with parametric design, but that's like sort of a rule-based design. I can show you examples later, but to save time, you want to make design rules for repetitive tasks. So, for example, one rule could be place a bridge railing post every 2 meters. And once you've written that rule, even though the road line is changed to the position, then the rule will help you redesign this in a new position. So, well over half of this bridge model is done with parametric design, but the resources to do this, we didn't have that in Norway, so we had to pick Sweco colleagues from Denmark and Finland and Poland to have enough resources. So again, we needed cloud-based design and cloud-based sharing to be able to do this. So that was maybe one of the first challenges. The second challenge was, I think the second challenge worth mentioning might be, let's see, I'll just have a look at my notes where what I would say was the second worst thing. Maybe a very huge model. When you make a BIM model of it, it becomes extremely slow. So you have to divide your model into submodels. So where we would divide it was quite important. So that was one challenge. A third one was, let's see, I'm just having a look at my notes here. To quality control it, you sort of have to, in a drawing, you can say, I'm controlling a principle, and this principle applies for all 7 columns. And in a drawing, you need to, no, in a BIM model, you need to quality control every one of the 200,000 rebars in the model. So doing that in an efficient way was also a challenge that we had to come up with a good solution, where the solution was good standardization of rebars, so that if you checked one rebar, you knew you had checked 100 rebars. That's 3 of them. Yeah, another very important one was when you do drawings, again, you have you're showing a principle that can be applied for many places in a bridge. While in a BIM model, you actually have to show the person building it the exact place where they're going to build it. So you need an easy way to do sectioning of the models and apply metadata to a section very easily. I don't know, does that make sense?
Yes, I would say you have to put geography to it, right?
Yeah. So you want to filter it down. You don't want to show 200,000 rebars to a person that's going to place 2 of them. You want to show those 2 rebars. So making those work packages in an efficient way, we had no software that could do that in an easy way. So we had to work with software vendors to help us do that more efficiently. And that is still a bottleneck today, but it's becoming better.
So is that essentially what the challenge is? Like, hey, we can model this thing, right? We can have all this intricate data surrounding it and all this detail. But in the end, this needs to be presented to somebody that can actually build it without overwhelming them. Is that kind of the idea?
Yeah, I think what you're describing, just that sentence, is the most difficult thing about this way of working. It's still a bit of a bottleneck, and that's why we're so happy that more and more countries and more companies are getting involved in this, because it will have software vendors. They will focus on this problem, and that's when that happens. That's when we'll see a revolution, I think, in this way of working.
Yeah, absolutely. I think that's an important part. So someone coming from the software industry, I can give you so when you have something brand new, right? So it's we will have gone and spoken to people like yourself and other people that maybe are in the field and saying, how do you think this would work? Mm-hmm. Right? And everybody's going to say, I think it would work this way. Mm-hmm. So therefore we would build the software, build the interface accordingly. Mm-hmm. But in the end, when they have to actually do it. And then, a lot of times it's oh crap, nope, that was wrong. Let's adjust it. There's continual iteration on there. So it's extremely important to get people that are utilizing it. So I would imagine that the next piece is obviously getting more and more contractors to adopt the usage of digital technology in the field. Mm-hmm.
Yeah, and we had a close. This was a design and build contract, so we worked very closely with the contractor and they taught us a lot of ways they would like the data to be presented. So we had a chance to sort of iteratively improve our project and product. And we had some very, very talented people at the contractor's office receiving our models and then utilizing it in very impressive ways. So we were very happy with that. But still, this way of working is in its infancy. So there's a lot of things to improve still. And I don't want to, maybe in 10 years we find out that there's other even better ways of doing design and building things. But I've been asking people and trying to understand, are we on the right track? Like skipping drawings, doing digital 3D models, is it the obvious way forward? Because I don't always feel it is. But most of the people I talk to say they think this is the way forward, at least the ones who've tried it. And if we see into the future where we want to digitalize to do automation at sites, you might have machines and robots doing more and more of the work, then it wouldn't make sense to feed these machines 2D drawings. So at some point you got to digitalize, but once you've digitalized it, you need people to understand it as well as the machines. So that's why I think this is the natural way forward.
Absolutely. Yeah. I mean, we're definitely in this like intermediary position where maybe for lack of a better terminology, it's awkward, right? If not everybody knows exactly how it's supposed to work, we're gonna come up with plans, we're gonna execute, and we're gonna continue to make it better. So we've talked about the fact that, all right, we're gonna move from 2D drawings to 3D, and it's digital, so it's better. Well, let's get into a little bit of the detail of like, why is it better? What benefits does it create? And more specifically on this project, what benefits did it create?
Just to do a brief history, like referring to the Norwegian road authorities, they have quite good data on project costs, and they had when all projects were done by drawings and drawings alone, they would have 19% of project cost. It would be overrun by 19% due to change orders. And then maybe 10 years or so, they said that all drawings made has to be based on BIM models. So whatever your product is, it needs to be based on a BIM model. And then they would see the change orders, project cost change orders would go down from the 19% to about 8%. So that was a huge improvement in quality and people understanding the scope of work. And now we see it increases even more than, it's down from 8% to, I don't have exact numbers, but we're now it's down even more. So I think that's the main thing. The second thing is that both for designers and people at site, understanding your scope of work is easier. Bill of quantities are more exact because everything is modeled. We normally in a project like this, we would, I'd say, receive maybe 2 or 3 queries a week on different questions. On this project, we were maybe down to 1 every second week. So the available data would explain how things would be done in a much better way. And fitting, for example, we have some special products like a joint at the end of the bridge where the bridge meets land, and the bridge of course expands, and So you need a joint there, and this is a very, very complex piece of equipment. So normally the producers would spend maybe 2 or 3 days at the installation of these, and on this bridge they spend 1 hour just supervising. So things like that does save quite a lot of time and money. So I think maybe that's the second best reason to go for this.
So I think in reading that article, it described, this is going to be my words, not the article's words, but it was all of the incremental changes due to variations in installation that normally in a 2D drawing set would end up getting missed or overlooked because of the time it took from the progress scan to then be brought back into the model, adjusted within the model, converted back to 2D drawings, and then made available again into the field. That these incremental changes build up, and then all of a sudden it's like oh my gosh, we're X amount of meters off, or whatever it might be, and therefore the change orders ensue because things have to go. So it was the immediacy of the progress scan feedback that made a big difference on implementation and execution in the field. Did I grasp that concept correctly?
Yeah, I think you're spot on. Because on a project like this, you would normally need about, say, 200 drawings, and every one of those would, in average, maybe have 5 or 6 revisions. So you would end up with well over 1,000 different revision versions, and the chance of every worker having the latest revision of every drawing is next to none. While all of these deliveries were cloud-based, so wherever they access the model, whether that be an iPad or a BIM kiosk or whatever, they would always have the latest revision available. So that was certainly an advantage, as you mentioned. Also, early on in the project, when you're doing basic design, then of course having a BIM model or a design to class check with other disciplines very early on gives you a very high impact, and the cost of changes are a lot lower than later on in the project. So that would be one advantage as well.
Well, this is awesome. We're actually at the final question. We'll love this, and also Øystein, I know that you had some models to actually show. So what we'll do is we'll take those and we'll share these along with the episode. So we'll create links so that everybody can kind of see some of the models that were utilized for this bridge installation in the Oslo, Norway area. But final question has nothing to do with bridge or BIM or anything like that. We ask all of our guests to share a motto, either their own personal motto that they live by or something that they've found intriguing or interesting to help with their work life or their personal life.
I thought long and hard about this, and I found one very good one. The best way to predict the future is to create it.
Oh, I like it. I like that one. You make your own.
Yeah, you make your 3D bridges without drawings.
Exactly. So for all of our listeners and viewers out there, they want to see more of your stuff. They want to connect with you. How do they connect with you?
I think the easiest way is to find my name on LinkedIn. Øystein Ulvestad, Øystein. Ulvestad is Ulvestad. And I'm happy to connect, and I try to post links of what we're doing frequently. And I'd love to hear other people's take on this. And the more people, more companies that are involved, the more the improvement. So sharing is caring.
That's awesome. Well, again, thank you so much for coming on the show. I've loved this conversation. Really intriguing. Really top of mind, especially here in the United States, with all the infrastructure projects that are kicking off, and something to really strive for. So thank you very much for sharing all that information. Everybody, thank you so much for tuning in, for listening, for watching. We're again so thankful for Øystein for joining us, and thank you all for showing up and listening to us blather on for 30 minutes. So until next time, stay connected, everybody.
Thank you for joining us for this episode of the Connected Construction Show. For more information, visit us at connectedconstructionshow.com.